Grooper's document separation capabilities streamline capture processes by replacing separator sheets with reliable, automated separation. In document capture terms, separation is a process that splits a sequence of raw pages into documents. The most common application for document separation technology is in production document scanning, where large stacks of paper are scanned in batches for efficiency purposes. For example, scanning a stack of college transcripts produces a batch containing 10 loose pages. Separation is the mechanism that assembles the pages into individual documents. Separation considerations impact virtually all production image capture projects. Automation, or lack thereof, can be a key factor in the overall cost of document scanning operations. Legacy capture platforms rely largely on separator sheets, which are inserted during document prep. While reliable, this method is costly, time-consuming, and rather wasteful. Options that don't require separator sheets are limited, require expensive add-on licensing, and can require months of professional services to deploy. Grooper's automated document separation is based on cutting-edge research in the fields of computer vision, pattern recognition, fuzzy matching, and machine learning. It represents a new breed of document separation capabilities engineered to handle the complexity, lack of structure, and imperfections found in real-world documents. Organizations can leverage these capabilities to eliminate costly, inefficient legacy separation mechanisms. The document separation mechanisms available in Grooper fall into two broad categories: visual separation and lexical separation. Visual separation uses image processing and computer vision technology and evaluates pages based on how they look. Visual separation mechanisms do not depend on optical character recognition, or OCR, and can be used in real time during scanning. Lexical separation is based on text analysis and pattern matching. All lexical separation mechanisms require OCR and cannot be used during scanning. Visual page recognition identifies separator pages based on how they look, using trained examples as a reference. It is designed for structured document types which have a consistent visual appearance, such as standardized forms. For example, consider a set of medical records where each record begins with a consistent face sheet. Once Grooper is trained to recognize a face sheet, separation can be triggered anytime one is encountered. This enables real-time separation and classification during scanning. Grooper can also separate based on the presence of stamps, seals, and logos, such as the filed stamp on a legal pleading. After training Grooper to recognize a filed stamp, this set of legal pleadings can be separated at each stamped page, even in real time during scanning. While visual page recognition identifies separator pages based on how they look, lexical page recognition identifies them through analysis of text content. Lexical page recognition can handle semi-structured documents, where pages may not look exactly like trained examples, but they generally provide the same information. Pattern-based separation leverages Grooper's pattern recognition and fuzzy matching capabilities to provide a rules-based approach to document separation, where separation is triggered by any page containing specific text patterns. Embedded page information, or EPI separation, uses page numbering embedded in the document content to perform separation. Change in value separation is designed for document types that repeat a standard header on each page. It binds the documents together based on a common data value, such as the invoice number on an invoice document. Anytime the value changes, a new document is created. As another example, college transcripts can be separated using the student ID as a binding value. In this case, a new document will be created each time the student ID changes. ESP auto-separation performs automated separation of complex, unstructured case files, such as personnel files, legal case files, mortgage files, student records, or well records. Based on a trainable machine learning engine, ESP auto-separation is fast and easy to configure and can handle batches containing hundreds of different document types. For example, scanning this mortgage file produces a batch containing more than 200 loose pages. At this point, there is no indication where one document ends and the next one begins. The output is simply a sequence of pages. After scanning, The batch is processed through a series of automated activities that OCR, classify, and separate the pages. The final step in the process is a review step, where a human operator can review and resolve any exceptions. Grooper's review module provides fast and efficient human review of exceptions that occurred during separation. Features such as drag and drop or copy and paste can be used to rearrange pages quickly and easily, while keyboard shortcuts provide quick access to a variety of functions that split, merge, and append pages. During review, operators can skip directly from one problem to the next, allowing fast and efficient validation of large batches. As review work is performed, Grooper logs detailed statistics on user activity and makes these statistics available through various Grooper reports. In this case, the entire review process for a 200-page mortgage required only 38 seconds. For more information about Grooper, please visit our website at www.bisok.com.